Our world runs on systems that are just mind-bogglingly complex. From the global logistics that get you a package overnight to all the smart devices in our homes, the scale is just huge. Today, we're going to dive into two brilliant blueprints from computer science that are designed to tame this complexity once and for all.
See, underneath the surface of our everyday lives, there are really two constant, fundamental battles being waged in our technology. They're these invisible forces that determine whether things work together smoothly or just grind to a frustrating halt.
So on one hand, you've got the challenge of connection. You could think of it like a massive global teamwork problem. How in the world do you get billions of different smart devices, built by totally different companies, to just start working together as a team? And on the other hand, you have the challenge of decision. This is an optimization problem on a just colossal scale. When you have millions of choices, how do you find that one perfect plan without it taking, forever to figure out?
And look, these aren't just some abstract puzzles for academics. They have huge, real-world consequences. And that's exactly why researchers are developing some radical new solutions. So we're going to break down two of them, each one tackling one of these epic challenges head-on.
All right, first up, let's tackle that connection problem. How do we get all our tech to stop acting like a bunch of isolated islands and start working together like one big unified continent?
Picture this, a disaster zone. It's chaotic. You've got rescue drones from one agency, ground robots from another, and environmental sensors from a third. In that kind of situation, there's absolutely no time for a team of engineers to sit down and manually try to get them all talking to each other. So what if they could just find each other and form a coordinated rescue team instantly and all on their own? That's the dream.
But right now, that's basically a fantasy. We live in a world of these technological islands. A smart plug from one company doesn't speak the same language as a sensor from another. This means the only way to get them to work together is to manually integrate them. And that's slow, it's expensive, and it just flat out doesn't work when things are changing fast.
So we need a totally new approach. And the solution being proposed is honestly beautiful in its simplicity. The idea is you give every single device a digital passport that describes it perfectly, and then you teach all the devices a universal language, so they can read anyone else's passport.
Okay, so this digital passport has a technical name. It's called a HOLON. And this isn't just a name and a model number. A HOLON is a super detailed, machine-readable profile. It tells other systems everything they could possibly need to know. What can it do? What's its battery level? Where is it right now? How do I talk to it? I mean, everything. But here's the thing. A passport is totally useless if nobody can read it, right? That's where the ontology comes in. Think of the ontology as the universal translator. It's the shared vocabulary and grammar that all the systems agree to use. So when one system sees another's HOLON, it uses the ontology to understand exactly what it is, what it can do, and how they might be able to work together.
So how does this all come together? Well, it's a simple three-step cycle. First, a developer specifies the HOLON for their device using that universal language. Simple enough. Second, the device turns on and just starts to broadcast its passport to anyone nearby. And third, and this is where the magic happens, other systems hear that broadcast, read the passport, and automatically compose a brand new team. They form what's called a super HOLON, a new, more capable system, created on the fly with zero human help.
All right, so we've seen a blueprint for connecting systems. But what happens when those connected systems need to make a massive, incredibly complex decision? Let's pivot to our second front, the challenge of making the perfect choice.
This quote just nails the problem. For a huge global company, planning their supply chain involves literally millions of variables. Which factory to use, which shipping route to take, how much to keep in stock. Finding the single best, mathematically optimal plan is a type of problem that can take so long to solve that by the time you get the perfect answer, the real world has already changed, and the answer is useless.
So, to tackle this, researchers developed an AI framework called Propel. And honestly, the best way to think about Propel is like a super intelligent assistant. It doesn't try to replace the master planner or the main software. Instead, it does the one thing that helps the most. It makes the problem dramatically simpler before the planner even gets started.
And here's the really clever insight behind this whole thing. In these giant optimization problems, a huge percentage of the variables in the final perfect answer are actually just zero. For example, if you're just not going to use that specific factory, or you're not going to send a truck down that particular road. Propel doesn't try to guess the exact number of things to make. It just predicts which options won't be used at all.
Propel pulls this off with a really smart two-phase attack. The first part, called prop, acts like a pruner. It uses machine learning on past data to figure out which variables are probably going to be zero, and it just snips them right out of the problem.
That makes the whole puzzle way, way smaller. But what if it cuts too much? Well, that's where the second phase, enlarge, comes in. It's a different kind of AI that acts as a refiner. If the first solution isn't quite good enough, enlarge intelligently figures out which of those zeroed-out options to add back in to find an even better plan.
So how well does it actually work? Well, the results are incredible. The research showed that Propel gets an 88% reduction in something called the primal gap. Now, the primal gap is basically just the distance between a pretty good answer and the absolute perfect answer. So getting 88% closer to perfect in the same amount of time, that is a massive leap forward.
And this chart tells the other half of the story. It isn't just about the quality of the answer, it's about speed. By making the problem so much simpler from the very beginning, Propel lets planners find these incredibly high-quality solutions in a tiny fraction of the time. This means they can react to changes in the market way faster and much more effectively.
So, we've looked at two very distinct challenges and two really powerful solutions. Now let's pull the camera back a bit and see what kind of future these blueprints are building when we imagine them working together.
So let's recap. We have two amazing ideas from different corners of computer science, but they share one powerful goal: automating away complexity. Holons and ontologies solve the connection problem, using that digital passport and universal language to let systems form their own teams. Meanwhile, Propel solves the decision problem by using AI to cleverly prune down impossibly large choices into something manageable.
So what's the bottom line? What does this all mean for us? Well, it means our environments, from our smart homes to entire smart cities, can become way more responsive and intelligent. It means the huge global systems we all rely on can make better decisions, much faster. For the people building this stuff, it means they can stop wrestling with tiny details and focus on the big picture. But maybe most importantly, it shows us a new role for AI, not just as a tool that makes predictions, but as a powerful simplifier that makes the impossibly complex possible.
And that brings us to a final, really big question to chew on. If these kinds of tools actually succeed in automating away all the technical complexity that bogs us down today, that frees up an incredible amount of human brain power and potential. So the real question is, what grand challenges in science, in society, in exploration should we be setting our sights on next?